Good morning, guys. Today we are back with another problem of binary search tree. So in this problem statement, what we can see and clearly assume that the trees are present, okay, and we have to print the sum of the elements in a particular tree. So it is like this in a vertical line of the tree. So if you see this particular diagram over here, I'm zooming in and focusing on the diagram a bit more. So you can see that 1, 2, 3, 4, 5, 6, and 7 is there, right? So when we are imagining one line on top of this 4, there is no other element, so the sum over here should be 4. Say for example, come to the next set of line on the tree. You can see 2 is the only thing which can be possibly placed on a vertical line. If imaginarily drawn from above 2 and below 2, there are no other elements, right? So 2 will be that only element. Let's come to this particular thing. After 2 line number 3 has 3 elements, 5, 6 and 1. So if you take the addition of 5, 6 and 1, which come under one line, 5, 6 and 1 come under one line. Be very careful while you are constructing an imaginary line. So the elements which are coinciding on this line will be 5, 6 and 1. So the sum will be 12. For the second, third and fourth line, you can see only element 3 is present, so the sum will be 3. And for the last or the fourth, 1 2 1 and 2 3 4 and fifth line, you will see only 7 is present. So you can see the output as 4 2 12 3 and 7. Okay, let's go to another example. So in this big example, what we can carefully see is 1 2 3 4 and 6 and 7. So you can see you have to place one line after another. So you can see there will be 7 different lines. No one is coinciding on any of the lines, so there will be 7 different lines. So the output will be 7 6 5 4 3 2 1, since one element is present individually in each of the lines. So this was today's problem statement. So before you jump into this problem statement, this also comes under tree data structures. So if you see over here, the topic tags is tree data structure. So you have to be very careful, and your knowledge on tree data structure should be in good as well. So first we can see we have a class ArrayList and vertical sum. So before doing a vertical sum, we have to make a function. So like I can write it as private void solve. So in private void solve, what I can do is I can take a node root and tree map. Since we have already studied hash map, hash set and all those things, tree map can be also defined like this. And in the tree map, the type you can pass two values. Sorry. So yeah, in the tree map, private void node root, then we have to take a tree map. So tree map of type integer. So what will be the tree map? So if you see in the integer tree map, I will take integer. Yeah, the tree map is being done. So once the tree map is being constructed, next is sum map. I have to take the name of the tree map, say for example sum, and another level, right? So one is level, one is this name of the tree map is sum, and there is a level which decides on which level of the tree you are. So say for example in private void solve, when we are solving, first our base conditions, whether the root equals to null, then what we will return like this. If does not, if sum dot contains key over here level, so sum doesn't contain any keys, so what we can do is we can add sum dot put two parameters, level and 0. Now you will ask me, Arnav, why we are taking two parameters? Because you can see like in tree map they have two parameters, both has to be integers. So I have to put over here level, and one is this. So for checking the tree, okay. Lastly, I have to think of the recursive function, because we have to solve this, right? So first sum dot put, I can write like this because the name of the thing is sum dot put levels So I can write like this as just a minute. So I can write like this as sum dot put as level, comma, sum dot get of level, and plus the current value of the root. So root dot data. Next, recursively call the solve function and root dot left sum level minus 1 solve root dot right sum level plus 1. So I can write over here level plus minus 1 and level as for taking of left tree, taking an element of right tree. So once this is done, the solve functions are being created. What we can try is this function is also done. Now we have to work on the our main function where we will define and take the value. So let's take an array list answer, create a new list, array list of type integer. You all know by now how to create an array list because I've solved so many problems on array list. If you don't know, just visit some of my previous problems. You will be used to it. Okay, so I've created one array list answer. Then I have to create a dummy tree map. So of integer type, say result tree map. Name of the tree map should be result, and equals to new tree map. Say I've taken a new tree map result. Okay, now what I can do is I can just simply call the solve function. So solve the root which is taken, and the uh, result which is the tree map, and levels as 0. So let's put a for loop for map dot entry. So whenever we are doing the entry of that particular thing, right, so we have to take uh, integer comma integer. So integer is being taken, the entry is also done. So over here entry I can write like this as the name result dot entry set. Yeah, so this is a pretty big loop condition. So in this nothing, I have to add the elements. So answer dot add, where did I go, answer dot add. I have to add individual answers to the array list. So entry dot entry entry dot get value, because I've, yeah. So once this for loop is done, we can simply return the answer. Class solution. Let's compile. So integer entry map dot entry, then entry result result dot entry, maybe a capital Z. Solve cannot take solve root level. So the level int level, yeah, I have defined sum dot level -1. Sorry, I have to take sum comma level +1. So yeah, so we have completed this question on tree data structure, array list, and binary tree all together. So it was a medium level. It's a tough question, but I hope you will study the data structures and would be able to solve this type of problems easily. Thank you. See you in our next video.